Okay. Now you'll find, I think well, everybody wasn't here last week, so it looks like that. And you can find it in Brightspace. In fact, let me show you where it is in Brightspace. Let me stop this share. And let's see. I want to share share my browser. If it's open, yeah, there it is. Okay, there's my browser. Now what I need is to get all this crap out of the way. Where am I going? Mail, post. That's Zoom. How about, yeah, let's go from here. So I'm going to go to content. Okay, let's go back over here and go to start here. Okay, and go down to learning modules and lab exercises. There we go. Okay, now we got our lab exercises. I'm going to collapse everything. It'll let me. Number 5, here we go. Nope, wait a minute. So it was number 4? Oh, it's number 5. I've got them wrong in here. Waters of constitution and hydration is here. It's lab number 4, but I think I didn't consider well, there's safety, graphing techniques, lab techniques. Oh, Boyle's law. Okay, Boyle's law is out of order, right? So that means that Boyle's law was 4, and the one we're doing next is 5. Okay, that's why. I got them out of order. Okay, so if you click on this one, what you see is what you've seen before is the document. Right, there's the exercise. And it appears to be open. Is the Waters of Constitution Hydration demo. There's also a discussion in here, PDF document. But if you click on the demo, it's going to take you to the YouTube link. And obviously it's got a commercial. You can skip that.
The correct number. You can just a little bit free. You can see.
Okay, so you'll recognize the surroundings. I think is not the same as this lab. I shot this video in on the New River campus, and all of these demo videos were made during the Corona panic. So I'm going to take this document and I'm going to treat it as if I'm a student, except that I'm wearing a GoPro cam on my head. And what you'll see is both the activities that you need to record as procedures and the data that's collected. I think I put it on the board.
Yes.
Yeah, okay. So I made a table there with
blanks in there for information that you're going to collect.
There you go. Okay, so the data is going to be right there. And you just need to be sure that when you write the procedure, you write it in the third person passive past tense, like the rubric expects. And put yourself in my place. And actually, the third person passive past tense allows you to not even put yourself in there. Because you say, this was done, this was done, this was done. And you don't have to say that I did this or or the instructor did this. You just say it was done. Okay, so that's what you'll look at in order to get the information you need to write the report. Now let's talk about the procedure itself. Let's see, close that, and let's go back to this and see if there's anything else in there. I think there was a discussion document. I'm not sure what that one is. It might be. Yeah, it's in the hard copy, or it should be. Maybe I better check to be sure. All right, so let's go in and let's go to the assignment and open this document. All right, there it is. First of all, notice that we're not doing the flame test. Flame test never works. So we just throw it out, and the unknown hydrate is actually hydrated copper sulfate. Actually, copper 2 sulfate. And then it has some waters attached to it. Those are the waters of hydration. They are separate molecules of water in the crystal structure of copper 2 sulfate. That's the first experiment. And what you have to do is find out what is the coefficient for water. What that coefficient says is for every mole of that compound, you have X moles of water. Okay, so you're looking for a mole ratio of water to copper sulfate. And when it says unknown hydrate, it's the hydrated copper sulfate. Let's see, for the second one, the second experiment, the thermal decomposition of sodium hydrogen carbonate, that's the waters of constitution. The difference is this, you can see the water in the formula. But for baking soda, bicarbonate, that's right. For baking soda, you don't know that there's water in there until you heat it. And it releases water. That's water of constitution. So what we're looking at is when we heat this, it produces a solid and it produces water and something else. It could be this, it could be this, right? We don't know. That's why I put that discussion in there on those back pages, because it goes through the detective search for what could this possibly be that makes sense stoichiometrically. And then there's one test that you do on the solid, or that I will do in the demonstration. You put this in water, you make it aqueous, and you add hydrochloric acid. It can do one of two things. It can do nothing, or it can fizz. If it fizzes, read the discussion. And it gets to the, and when it gets to the part where it says that solid could be one of these, it could be this one, that one, or it could be this one, right? Sodium carbonate or sodium oxide. If it's this one, there's no fizz. If it's this one, there's a fizz. Okay? That's like a quick test to distinguish between the two. The other way that's in that discussion is to do a calculation on, if you start off with so many grams of this one, you have the mass of that one. And if it's sodium carbonate in a balanced equation, then you should be able to calculate what the mass is. If it's sodium oxide, it's a different equation, and you calculate the mass for the sodium oxide, and you compare what you actually get. Because you're going to start off with a known value here, then you're going to weigh it after you heat it. I use that term theoretically. And you're going to get a mass here, and you compare this mass to one of these two and see which one fits. That's your other confirmation in addition to the fizz. Okay, so read the discussion and carefully, and it will explain step by step the detective route that we take to find out what that solid is. And then, as one of the questions in the document asks you, what is the balanced equation for the decomposition of sodium hydrogen carbonate? Okay, you need to write that out to answer that question. Okay. Now let's do a little calculation using copper sulfate. That's the pre-lab question on the first page, right there. All right, that pre-lab question says, well, actually, it's not copper sulfate, it's gypsum. And I know what the water composition of gypsum is, but we're going to calculate it anyway. So we're looking at this, calcium sulfate, and that dot means waters will follow. A certain number of waters will follow. Okay? We want to determine the X. What is the mole ratio of water to calcium sulfate? The problem says you weigh some of this into a crucible. Hold on a second. All right. This is a crucible. Right? It's a ceramic. So if you drop it on the floor, it'll break. And this is the lid. That's the way it goes. Now, when you're heating whatever you put in there, you usually cock it off a little bit and leave a little bit of gap. You don't want to leave too much, just enough for the vapors to escape. And you keep the lid on it, because if it starts to spatter as it heats, then you want to keep everything inside the crucible. That's why when you weigh this without the material in it, you weigh it with the lid. And then when you put the material in it, you weigh it again with the lid. Then you heat it. And then you take it off the flame and you cool it down in a desiccator, like this. You put a substance in the bottom called dryerite, and then you put your hot material in here, put the lid on it, like that, and let it come to room temperature. You do it in a desiccator because you just heated it to expel water. If you leave it sitting out on the bench while it cools down, it's going to suck more water back in. And that kind of defeats the purpose. See, I lost my cap. Here it is. Okay. So you'll see that in the video too. All right, so when it says weigh some into a crucible, that's what we did. We weighed it into the crucible. Actually, we heated the crucible to drive off all the water and let it cool in the desiccator. Then we took it to the balance and added our material. So the crucible now weighs 38.0160. Yeah, that's not working too good. Let's try a different one. 38.0160 grams. And this is the crucible plus gypsum. What we usually say is wet. I mean, it's not really wet, but it still has water in it. Then the problem says the empty crucible weighs 33.0160. 33.0160 grams. This is the crucible with nothing in it. Now, how much does the gypsum weigh? Subtract the two. 5 grams. Okay? That's how much you put in there of this substance. Then you heat it, and you cool it in a desiccator, and then you weigh it again. So now we have crucible plus solid. It's not gypsum anymore because we got rid of the water. Crucible plus solid, and this is dry. That weight is 36.9405 grams. Okay? How much of that solid is in that crucible? We need to subtract the weight of the crucible. Right? So that's 5, that's 4, this is 2, that's 9, and this is 3. 3.9245 grams. This is before, this is after. Okay? Now, the question is, what's the value of X? In order to do the value of X, we need to convert everything to moles. Okay? This is the mass of that only. Right? So we know how to convert that. We need the molar mass of calcium sulfate. Right? So we got to add it up. Got to find out calcium. Right? Calcium is 40.08. Excuse me. Yeah, 40.08. Sulfur is 3207. And 4 oxygens is 16 times 4 is 64. So that's 136.15. All right. So that is how many moles of calcium sulfate we have. 3.9245. There we go. 2.88 times 10 to the minus 2 moles of calcium sulfate. How much water do we have? Because we have to ratio the moles. How much water is there? Well, it was this wet and this dry, so the amount of water is subtract calcium sulfate from the total. $1.0755. 1.0755 grams. And that's water. Right? We know how to find the number of moles. Water. What's the molar mass of water? Well, 2 hydrogens is 2.02, and water and oxygen is 16. So it's 18.02 grams. Divided into that value. So that's 5.97 times 10 to the minus 2 moles of water. Okay, what's the molar ratio of those two? Well, which one's bigger? This one's bigger than that one. So let's ratio this one on top and that one on the bottom. So this is 5.97 times 10 to the minus 2 moles of water per 2.88 times 10 to the minus 2 moles of calcium sulfate. So let's see, I've got these in my, I need to just flip them and then divide. So I get 2.07 moles of water per mole of calcium sulfate. Right? So the nearest whole number to that, which is where we have to round it, is 2. Okay? That's how to find the mole ratio for that value. And you do the same thing for copper sulfate. Just pay attention for these values as you go along. And of course, they're going to be written on the board too. And you can calculate. This is the easiest one. The sodium bicarbonate, sodium hydrogen carbonate experiment is a little more difficult. Any questions? There's a in the discussion, we talk about copper sulfate calculations. They're not the same as I actually did in the experiment, but the method is the same. So you should be able to follow that. And then the part 2 discussion has different scenarios. What could that solid possibly be, and what could those other products be? Carbon monoxide, carbon dioxide, water, obviously. And then it goes through different scenarios and describes to you how to distinguish between fact and fiction. A lot of these proposals are just completely ludicrous. And the discussion points that out. Okay? Any questions? What I did during the COVID panic was I had those demo videos locked down. And in order to get it open, you had to take pictures of your lab notebook set up properly for that experiment. And then I had to grade it with 80% or better results. Otherwise, you couldn't get into the demo. But I'm gonna cut you a break on this one. Set up your notebook to accept that information, fill it in, because I'm going to check it at the end of the term. Right? I'm going to do a final notebook check. And if it's not there, then that's lost points. So it's best to set it up now, because if you do that, it'll be easier to write the report. And then do that before you look at the video. Okay? Let's see. Oh yeah, I'm sharing this. There are some lab questions, but some of the lab questions I think reference results that you're going to report in the document that you submit. So if that's the case, you just go to the lab question, and when you list the question, say, refer to this section in the report. Right? There's no sense in you just repeating everything over again. Just show me where you did the work someplace else. Unless it's a special question and then you have to answer it right there. Okay, so we did the pre-lab question for you. That should be an easy one. Okay, well, I guess this is the whole class. We lost Kobe. So it's just us, instructor and us three. Okay, if there are no questions, then we're done for the day. And we'll, let me see. Right, next time we have an exam, so there won't be a lab. All right, so you have until 2 weeks from today. 2 weeks from today for the lab, the Waters of Constitution lab, to be turned in. That should be plenty of time. Next week we'll have an exam, and then we'll jump right into the next atomic structure and periodicity comes next. Okay, that's it then. We'll see you next week.